Well, welcome to the next module here in HFL 240. We're going to be looking at emergency power systems, a best practice approach as it relates to, I guess, a comprehensive review of disasters and emergencies over the last several dozen years. Um, we've learned a lot and a lot about errors in our thinking when it comes to our design of power systems and some of the requirements. Unfortunately, through hurricanes and through tornadoes and through floods and things like that, we've had to learn some hard lessons about how to install, design, and assess our equipment. Um, Generators, and I know anybody that is working in healthcare for any amount of time understands how critical the generator is. But sometimes I think what we miss is the complexity of our emergency system, and not just the emergency system, but the utility system, the distribution system, the transfer switch, and all the interrelated components of the system. We focus an awful lot on the generator itself and the transfer switches. But I think that as you work in healthcare, you start to realize that there are a lot of things beyond that one needs to consider. For example, I know that when I worked in my most recent facility, we were prone to all kinds of wind events where I lived. Hurricane, tropical storms, tornadoes, nor'easters, you name it. We would have these wind events. And when you have wind events, you would run into the situation where ultimately, typically it would be trees on above ground power lines where branches would be striking a tree, and when it hit the trees, and if a branch fell and didn't fall all the way to the ground, it would cause intermittent browning out, if you will, or shorting out of the system. And your facility would, your generator would kick on, kick off, kick on, kick off. It would never transfer, but it would maybe sometimes it would transfer. And when this is happening, I guess outside of normal business hours, it's maybe not as big of a deal. But when it's happening during business hours, next thing you know, your operational departments, your surgical departments, your outpatient departments, and other departments, their equipment is going through all kinds of issues. The IT equipment may be going through issues because when you get a transfer, even though generators are meant to transfer over within 10 seconds for critical systems, and it's usually somewhere between 5 and 8 seconds. That disruption, that momentary disruption, as you know, on most computer systems, causes everything to have to be reset or to start over, unless it's backed up by a UPS. And then also you find out, what UPSs you have that may or may not be working during those times as well. And when you have those situations, you have to make decisions. For example, can you continue to run your OR procedure? A physician in the OR, they can't tolerate time is an issue. So if you have let's say a C-arm that's being used for fluoroscopy while they do some sort of invasive procedure. Number one is if the lights go out for a short period of time, let's say all the lights go on the OR except for the emergency lights on the wall that come on. Well, those emergency lights really aren't sufficient to do proper surgery. And so, you can't have, 5 or 6, 7 seconds of darkness, and the physician may have to be frozen in a position until the light comes back on. Who knows what kind of place where he would be right at that moment. And if it starts cycling up and down, you're going to get issues with OR. We were on a practice at our facility. Actually, it changed when we were bought out by a corporate entity. But before that corporate entity bought us out, we knew that if we start seeing that typical cycle because of trees or whatever it might be, we would go on generator automatically. We would manually put ourselves on generator, and we would disconnect ourselves, if you will, from the normal power grid, so that way our system would stay on generator, so we could have smooth operations and have no disruptions. In some cases, as time moved on, we would do that just long enough until we could basically shut down the OR and finish up cases, and then we would cease to do cases, and we would go ahead and probably stay on generator or possibly go back to utility power and hope that we didn't keep browning out. But that was a practice that we had, and we did that proactively. We were involved, and when we would talk to the electric company and ask them if they what kind of situation it was. And that's the other interesting thing. Your relationship with the utility and your electric company needs to get really close. We had numbers. I've always had numbers, and was assigned a person within the company that I could call 24/7 to find out kind of what was really going on in the utility, because you couldn't always find out by calling the utility directly through their customer service line. But if you had a backdoor number, you would often find out what was really happening. Another complexity of generator systems, if you were to look into your book, there's a figure, and the figure is really, it's on page, it's 2.2, and it's figure 2.1. In that figure, it shows a basic distribution system. And you'll see in that image, you have the power plant, and you have the high voltage transmission lines, and that gets distributed down to a distribution substation. One of the things that you're going to want to know, or you will know when you're working with your distribution system, is, are you fed from one substation, or are you fed from two substations? It's a very important thing to know, because very often, we're meant to have, many hospitals have redundant feeds, power feeds to their hospital, but in many cases they're fed from the same substation. And substations will and do have problems. And so even if you have two feeds coming from different parts of the property, if it's from the same substation, and a substation has an issue, obviously you're going to lose, power, and you're going to be on generator. And we had the fortune in one Fortune 1 building, my second facility, that could be fed from two substations. And that was pretty handy. There were times, again, where we had issues with power that was bouncing around due to some form of intermittent issue, might again be wind and trees again. And what we would do is we would ask the power company to switch us over to the other substation. And that would solve our issues. So we had the opportunity to go from one substation to another substation. And you can see the benefit of that, of being able to go between substations. And then once you get past the substations, then you start getting down to your transformers, and you start getting your switch gear. And again, that's another very complex situation when it comes to facilities. What they have found in time is that very often switch gear, your generator may be fine, and it may be in a place where it's not going to be flooded, but your switch gear, your transformers are located in a low area where it could be flooded. So again, without your transformers and without your switch gear, you're dead in the water. You have a generator that runs, but you can't distribute power. And again, I'm talking about switch gear and transformers that are downline inside your facility, past your generator, not necessarily the ones that are before your generator, although the ones before your generator are also very critical to maintain, good power. You'd be surprised too over the years how many times we lost power due to animals such as squirrels. They get into into the wires, or they get into your equipment, and they can short out your equipment, or short out our switches, external switches outside. And I've seen that a few times happen, where we've been taken out by squirrels, which is always unfortunate for the squirrel, because they don't ever survive when they take you out like that. So when it comes to emergency powers, there's a number of reasons, a number of things as you as a facilities person need to understand beyond the generator and beyond your internal equipment. One of the things too that goes on is load shedding, which is a pretty critical issue. I believe it may or may not be discussed here, but there are times where if you ever had to run on a generator for an extended period of time, there's a curve and there's a load that generator can handle. And very often when things are designed, you may have plenty of capacity in that generator for most scenarios. But as time goes on, rarely do you upgrade your generator capacity, but you definitely end up adding more and more and more emergency power onto your system. And what ends up happening is that you get into an extended period where you need your generator, and next thing you know, your generator is running at such high capacity that you have the potential to essentially burn up your generator. We've had situations where, for extended runs, where we have seen the exhaust stack glow to the point of being able to see essentially right through it. That's how hot our generator got during one hurricane or tropical storm. And of course, one other thing related to generators is the amount of air intake that's required for a generator. They suck a lot of air. And when that happens, we had a situation where we had unintentionally built an extension of our plant to add some chiller capacity. And what we didn't realize was we had built it close enough to the intake of the generator that we essentially were starving the generator partially of air. And we were testing our generator, and we couldn't reach 100%, or really we couldn't reach 90% capacity of the generator's output because of its location, because it couldn't get enough air. It would start to overheat and would start to have problems. So we actually had to sort of derate the generator because of that, or completely turn the generator or relocate the generator, which we didn't do because we were going to be building a new facility. So there's a lot of things that one has to consider when it comes to generators, beyond which really one of the most critical things, and that's the operations, the maintenance, and the testing of the generators. I think that's where most facility managers get focus, of course, is the monthly and the weekly tests, and getting those details right, and making sure that's done reliably and consistently, as well as the required load sheds, load runs. And again, speaking of load runs, that's another issue that you're constantly struggling with if you have a smaller facility, and that is, we all want to get 30% of our plate rating during our monthly runs so that we don't have to do the annual run. And it is difficult at times, picking the time of day so you don't disrupt operations, being able to transfer your load, which means you're going to be bringing over transfer switches that have load on them. In some cases, you might even have to turn things on around your building to get enough load to make sure you can get your 30%. But in many cases, you can't. It's just too disruptive. So you have to just settle for not running at 30% and doing an annual load bank test on your generators to get, I believe the load bank is a 30, 60, and 90% for each one has a certain amount of time. I think it's up to 4 hours total for running your different loads up to 90% for an extended period of time once a year. And that's pretty expensive. And again, you also run into a little bit of an issue with safety because when you're tied to your load bank, you can't necessarily come over to generator right away. So you have to do a risk assessment, and you may even have to bring in a redundant system just to do the load bank. So, a lot of things go into generators and operating generators and maintaining generators. And then, as you work with them over time, you gain this experience. And hopefully what's going to happen with this book is we're going to be able to gain a lot of experience or a lot of awareness that, you wouldn't be able to gain except through going through it, year after year, season after season. So, the first couple chapters of this book, first we lay out really, the different types of emergency, if you will, systems or legal systems or, optional systems or critical systems. And you get a nice clear definition. You get a nice understanding that NFPA 70 is a core area when it comes to, how these things are, what's meant to be installed and the electrical requirements. Some of you are thinking, well, what about 110? I thought 110 did that. Well, 110 is really about maintenance, operations, and testing. It's not really about installation and the more detailed requirements of electrical systems. 70 is where you'll find that. And then you get into more case studies here about different type of events that can cause you to have to need a generator for an extended period of time. One of the other interesting things when it comes to generators that you'll run into over time is that when you have automatic transfer switches, that delay, that 5 to 10 second delay from when you lose power to when power comes on, people interpret that very, very differently. You'll have some people say that it felt like a minute, and typically that's what it is. They feel like they were in the dark for a very long time. But one other things to distinguish is that not all transfer switches have to come over at within 10 seconds. You may have an emergency system that has a transfer switch that is tied to, let's say, a business office. It's a business function, pure business, not patient, not clinical at all. It may be an extension or a building that's with its own transfer switch, with its own panels and everything else. And you may choose to bring that system over much slower, so that way you can phase your loads in. And when you do that, those folks may not understand, well, how come, it took, forever, maybe 15 seconds, to bring that system online, whereas maybe, of course it was 5 to 10 seconds for the rest of the hospital. And it's hard for the public to understand that, but certainly you don't want to bring your load in all at one time. You want to phase your loads. Another related item is that sometimes what you do is you phase your mechanical loads because they are such a heavy load and they're not necessarily critical systems. You don't have to bring those on necessarily either within 10 seconds. And sometimes that can be a little confusing for some folks. And then, of course, you get to manual switches. And manual switches really are loads that you when you have a generator, you want to protect your generator. There are times that you want to phase some loads in because if it's a worst case scenario, you may have so much going on in your building with your automatic transfer switches that it may not be safe to bring certain loads online because it may push your generator system too hard. And also, in some cases, you may lose a generator. Let's say you have 3 generators, 2 primary that you need, and a third is sort of a N+1 design, so it's a backup in case one of the 2 fail. Well, you may have a scenario where if you're in extended outage and you lose, it could happen. You lose, let's say, 2 generators, and you're down to 1 generator. Well, you're going to want to load shed, and you're going to want to have the ability to take things offline. And again, sometimes manual switches are designed for that. They're designed to say, okay, if I am running my hospital and I'm in a worst case scenario where I have to make a decision what I'm going to keep running and what I'm going to shed, I want the ability to take my chillers offline. I want the ability to take my heavy loads offline. And essentially, it's almost like triaging your hospital. You're going to protect just the most critical systems, and keep the ICU and keep the ER and keep maybe again the OR, some critical spaces running, but let go of your chillers. And nobody wants to be in those situations, of course. But as a facilities manager and director, you need to know your system well enough. You need to know your load shedding and your transfer switches well enough to be able to do that. This is really that Scotty moment of Star Trek where that's engineering. This is what we have to know in case we get into those scenarios. And they're hard to practice. I would suggest that your team practice these things. That it'd be kind of fun. I think it's very engaging to tell your team, okay, folks, we're on emergency power, and we just lost one of our generators, and we have to figure out what we can load shed. How are we going to load shed it? And hopefully you have a policy and a procedure for that. But in many places you don't. And if you have it, in many cases your staff aren't familiar how to do it. And in fact, I've seen where staff, they lack a lot of confidence to do this because it is a big deal to manually shed loads. It is a very big deal. And what I found was that, but if you practiced and if you had good procedures, it really wasn't as big of a deal. It really wasn't. They felt confident, and they said, okay, we know what we can do. And we can do, A, B, C, and D to triage our facility. And fortunately or unfortunately, I have been in those situations, and I've seen when staff aren't confident in doing it, or they lack the knowledge or the skill set to do this because it happens so infrequently. And this is something that is going to happen very infrequently. If it's happening all the time, it shouldn't be happening all the time. If it is, you got a major problem with the utility company, or you're living in a very dangerous place. But that being said, it's going to happen enough over time, whether through hurricanes and ice storms and tornadoes and wind events and floods and otherwise, or car accidents, that you're going to get experience over time with generators. And hopefully what we do with this book is we expedite a lot of the stuff that takes years and years and years for most facility managers to experience. So that's the hope of the book. It's not the best book in terms of understanding generators, but it is a really good book at helping you gain experience on not just the design and layout of generators, a general understanding, but really let you know some of the things that can happen, and then how can you assess a system and be more prepared to understand your system and how to respond in case you have to deal with an emergency or a disaster. Well, that's the hope of the book. I hope you enjoyed this little 20-minute intro. and me sharing a little bit of what I've gone through in my career.